Hello. In this video, we will be going over the Concept 1 Teacher Talk. At this point, please make sure you have completed the Teacher Talk so that as I go through this video, you can check your answers. In Set 1, we will be using the diagram to the right. And we're going to be doing three things. We're going to be naming all the different lines, all the different segments, and all the different rays. When doing this first problem, you could have multiple answers. So it states to name all the different lines. The name I decided to pick was line QD. Pay close attention to our notation. I picked the 2 points, and above those 2 points, I put a line with 2 arrows. For it to be a line, you need both arrows. However, there's only one line. You could have different names. 2 other possible names would be line QZ and line ZD. We have the same notation, we've just picked 2 different points. Other names could be the reverse as well, line DZ, line ZQ, and line DQ. You only need one of the names because there's one line, but you could have the 6 different possible names. The second part says to name all the different segments. One possible segment is segment QZ. Pay attention to the difference in our notation. We still have 2 letters, but now we just have a little segment with no arrows. The other segment would be segment ZD, and our final segment is segment QD. You do need all 3 here because we have 3 segments on this line. Again, you can switch the order on the names for these. So segment ZQ is the same as segment QZ. For the final part of set 1, it says to name all the different rays. One ray you should have named is ray QZ. When we are naming rays, the arrow for our notation should always point to the right. We're stating that the ray starts at point Q and is going towards point Z. Ray QD would be the same because you're still going through Z to get to D. So ray QZ and ray QD are the same ray. The next possible ray would be ray ZQ. Starting at point Z and going towards Q, which I know is to the left, but again, our notation is still to the right because we're starting at Z and going towards Q. ZD, so ray ZD starts at Z, goes towards D, and our final ray would be ray DQ. Again, ray DQ could also be called ray DZ. It's starting at the same point and going in the same direction. In set 2, it states to sketch line DE so that it intersects plane ABC at B. So we have a line, a plane, and a point. I personally would start by drawing your plane ABC. I have drawn a parallelogram and I've put on my parallelogram those 3 points. Please also note that I've made that those points could not be on the same line. Now that I have my plane, I'm going to draw my line DE through that point. So I have a line with 2 arrows, an arrow on each end, and I've added the point D and the point E to my line. Those could be anywhere on your line. What you might also realize that I have is these dashed lines where I've highlighted here. That's because my line's going through my plane, it's not on top. So at that little segment right there, it's kind of behind or underneath my plane, which is why I've changed it to a dashed line. In set 3, name the 3 planes that intersect in segment CD. One of these planes is not a side. So I went ahead and highlighted my segment CD and the bottom of my box. When we name a plane, we only need 3 letters. So that plane contains points M, Y, C, and D. And I'm going to pick 3 of those letters to name it. So I went ahead and named it plane D, M, Y. My other plane would be the right side of my box. So that side, that plane, contains points P, Z, C, and D. I picked 3 of those letters and named my plane P, Z, C. Our final plane is not a side. So, this plane is actually the diagonal cut of my box that I have kind of outlined here in blue and highlighted again in yellow. That plane contains points B, H, C, and D, and again picked 3 of those 4 letters to name it. Set 4. Without graphing, how could you determine if the points 2, 3, 5, 1, and 11, negative 3 are collinear? Lines that are on points that are on the same line will have the same slope. Again, points on the same line have the same slope. So I'm going to go ahead and write all 3 of my points kind of on top of each other like so. When we're looking at slope, we are looking at the differences of the y's and the differences of the x's. So from 2 to 5, I've gone up 3. From 3 to 1, I have gone down 2. That's why I have negative 2. From 5 to 11, positive 6. 1 to negative 3, I've gone down 4. Again, slope is the difference of my y's over my x's. So the slope between my first 2 points would be negative 2 over 3. And the slope of my next 2 points will be negative 4 over 6, but I'm going to reduce that. Negative 4 over 6 reduces to negative 2 over 3, which means they are the same line because my slopes are the same.